This serves as an informative historical exploration examining technological advancement and the life story of an innovator. The material addresses weaponry evolution through a strictly historical and pedagogical lens. During 1916, while countless servicemen perished within the muddy excavations of the First World War, an inventive American craftsman conceived a notion that military commanders deemed utterly preposterous. His vision involved converting a standard hunting firearm into a fully mechanized combat instrument. Military leadership ridiculed his proposal. Technical specialists declared the concept unachievable. Yet John Browning stood ready to engineer the deadliest armament of the entire 20th century, a mechanized firing apparatus destined to permanently transform battlefield methodology. This narrative chronicles the individual who possessed sufficient audacity to confront seemingly insurmountable obstacles. John Moses Browning entered existence during 1855 within Ogden, Utah. Born into a household thoroughly immersed in explosives and metallurgy, his patriarch, Jonathan Browning, operated as a frontier weapons craftsman who constructed firearms for pioneers and game hunters throughout America's western territories. The family's manufacturing facility connected directly to their residence, where the distinctive aromas of lubricating oils and metallic particles permeated John's formative years. By 7 years of age, while neighboring youngsters engaged in street amusements, young John already occupied the workbench, meticulously observing his father's every technical maneuver. He witnessed metal transformation under thermal application, observed component assembly with microscopic exactitude, and comprehended how elementary mechanisms could unleash precisely controlled explosive energy. For him, these instruments represented not tools of mortality, but rather intricate mechanical enigmas, awaiting resolution. At 13, John constructed his inaugural complete firearm utilizing exclusively discarded metallic fragments discovered throughout the workspace. The finished product proved not merely operational, but demonstrably superior to numerous commercially available firearms of that period. His father immediately recognized this young man possessed exceptional aptitude, extending beyond simple manual dexterity. John could mentally visualize elaborate mechanical systems, comprehend force distribution through interconnected gears and tension springs, and accurately predict component interaction under substantial pressure. The Browning household practiced the Mormon faith, which fundamentally influenced John's character development. He matured surrounded by principles emphasizing diligent labor, unwavering persistence, and conviction that divine providence bestowed talents upon individuals for humanity's collective advancement. John genuinely believed his mechanical genius served some elevated purpose beyond mere commercial enterprise. When he reached 19, his father died unexpectedly. John assumed control of the family workshop alongside his siblings. However, circumstances quickly revealed he transcended the traditional gunsmith role. He embodied a natural-born innovator. While competing craftsmen duplicated existing blueprints, John commenced entirely reconceptualizing firearm operational mechanics. During 1879, he secured his initial patent for a single-action rifle. The design proved revolutionary, markedly simpler, substantially more dependable, and considerably more accurate than any competing market offering. The Winchester Repeating Arms Company, representing one of America's premier firearms manufacturers, immediately acquired the patent rights. This transaction initiated a collaborative relationship spanning multiple decades. Throughout subsequent years, John generated an extraordinary succession of breakthrough innovations. He developed repeating rifles, pump-action shotguns, and semi-automatic pistols, each undertaking shattered technical barriers that rival engineers considered absolutely impossible. European manufacturers examined his blueprints with undisguised envy. Hunters and professional marksmen competed intensely to acquire his weaponry. Nevertheless, John harbored one particular fixation: creating a genuinely automatic weapon, capable of sustained fire throughout the duration of trigger depression. This concept captivated him not through any appetite for destruction, but rather due to the sheer technical challenge it presented. The engineering problems seemed overwhelming: harnessing shot energy to eject spent cartridges, chamber fresh ammunition, and fire repeatedly, controlling recoil forces, preventing thermal buildup and mechanical jamming. Military establishments demonstrated minimal interest during this period. Automatic weapons existed, particularly the Maxim machine gun, yet these proved enormous, cumbersome, mechanically complex, and prohibitively expensive. Nobody believed automatic weaponry could achieve practical battlefield application. John Browning prepared to invalidate every skeptical assessment. During an unremarkable summer afternoon in 1890, John Browning occupied a firing range evaluating one of his newest rifle designs. Each discharge generated heated gas clouds escaping the barrel following projectile expulsion. John scrutinized these gases with scientific attentiveness, as consistently practiced. For him, every discharge represented an applied physics experiment. Then occurred something destined to revolutionize firearms history eternally. While firing near ground level, John noticed exhaust fumes agitating surrounding vegetation. Grass stalks bent violently beneath the invisible gaseous force. This phenomenon had been witnessed by countless shooters throughout history, yet nobody had truly observed it through an inventor's perspective. John stood motionless, watching intently. His mind accelerated rapidly. Those gases possessed wasted power simply released atmospherically with each discharge. What if that energy could be captured? What if it could be redirected to operate the weapon's own mechanical systems? He rushed homeward to his workshop with excitement his siblings immediately recognized. When John displayed that particular expression, it signaled he had envisioned something genuinely revolutionary. For weeks, he labored over sketches and mathematical calculations. He needed creating a system channeling shot gases to activate a piston. This piston would eject spent cartridges, load fresh ammunition from the feeding belt, and prepare the weapon for subsequent discharge all automatically. The concept appeared brilliantly straightforward theoretically, yet proved extraordinarily complex during execution. The pressures involved reached enormous magnitudes. Timing demanded absolute perfection. If the mechanism opened prematurely, gases would escape without providing sufficient force. Opening too late would cause pressure damage to components. Gas temperature presented another complication. Overheated metal expanded and altered its material properties. John commenced constructing prototypes. The initial model exploded upon the testing platform. The second jammed following 3 discharges. The third functioned for 20 rounds before fracturing a tension spring. Each setback provided valuable learning. John never perceived failures, he perceived data. He adjusted dimensions by minuscule fractions, experimented with different metallurgical compositions, and modified spring angles and tension characteristics. His siblings occasionally questioned whether such extraordinary effort warranted continuation. After all, Winchester consistently purchased all his conventional rifle designs. They generated substantial profits. Why gamble everything on this unconventional automatic weapon concept nobody requested? Yet John was propelled by motivations transcending financial gain. It was the fundamental necessity to solve the problem. It was absolute certainty that achievement was possible, even when universal opinion declared otherwise. It was the vision of observing that grass movement and recognizing he had discovered a fundamental principle nobody else had comprehended. After months of obsessive dedication, he finally possessed a functional prototype. It was a gas-operated machine gun capable of continuous fire. He tested it secretly, discharging hundreds of rounds without cessation. The weapon heated substantially but remained intact. The mechanism operated like precision clockwork, even under extreme stress. John knew he had created something exceptional, though he didn't yet comprehend that moment observing grass movement would produce the most influential weapon throughout modern military history. During 1891, John Browning presented his novel automatic machine gun to the United States Army. He felt confident the weapon was technically superior to all alternatives. It was simpler than the Maxim, more reliable, and lighter. He had resolved problems other engineers considered impossible. The demonstration occurred at a military installation before high-ranking officers. John meticulously prepared the weapon, loaded the ammunition belt, and commenced the evaluation. The machine gun thundered, firing with impressive accuracy and consistency. Spent cartridges flew through the air. The distant target was completely obliterated within seconds. When silence returned, John anticipated applause. Instead, he encountered skeptical expressions and apparent disinterest. One general commented that the weapon was interesting as a technical curiosity, but lacked practical application. Another stated that machine guns were defensive equipment for fortifications, not field weapons. A third officer simply mentioned that the Army already possessed Maxim machine guns and saw no replacement necessity. John was bewildered. He attempted explaining the advantage a simpler design with fewer moving parts meant reduced failure probability. It was lighter, facilitating battlefield mobility. The gas-operated system was more efficient than the Maxim's recoil system. Every technical argument met polite disinterest. The reality was that 1891 military thinking remained rooted in 19th century tactical doctrine. Battles were decided by infantry formations marching in coordination, firing in synchronized volleys. Machine guns were viewed as specialized equipment for defending static positions. The concept that automatic weapons could completely revolutionize warfare had not yet penetrated conservative military consciousness. John returned to Ardennes frustrated, though not defeated. He knew his invention was revolutionary. If American military leadership couldn't recognize it, perhaps he needed alternative approaches. He began demonstrating the weapon to private manufacturers and foreign military representatives. Some expressed interest, but none committed to mass production for years. John continued perfecting the design while working on other projects. To maintain financial stability, he created the legendary Colt M1911 pistol, which would become the standard United States Army sidearm for 70 years. He developed new shotguns and rifles, but the automatic machine gun remained his unfulfilled passion. What John couldn't have anticipated was that the world was about to change dramatically. In Europe, political tensions were escalating. Rival empires were stockpiling weapons and forming dangerous alliances. Nationalism was inflaming populations. Territorial disputes were creating flashpoints across the continent. It was a pressure cooker awaiting explosion. In 1914, the assassination of an Austro-Hungarian archduke in Sarajevo ignited the fuse. Within weeks, all major European powers were at war. World War I had commenced, and with it came a combat form nobody had anticipated: trench warfare. Millions of men excavated holes in the earth and faced each other across open fields, covered in barbed wire. In this new and terrifying kind of warfare, machine guns suddenly became the most critical weapons on the battlefield, and John Browning had precisely what the world needed. The trenches of World War I created a combat type nobody had imagined. On one side, soldiers took shelter in deep ditches protected by barbed wire and sandbags. On the other side, just a few hundred meters away, enemies did the same. Between them stretched no man's land, an open field of mud, craters, and death. Traditional military tactics collapsed confronting this reality. Generals ordered attacks in which thousands of soldiers would leave their trenches and rush toward enemy lines. It was organized suicide. Machine guns positioned in enemy trenches massacred the attackers before they could get close. In a single day of the Battle of the Somme, the British Army lost 60,000 men, most of them killed by machine gun fire. Machine guns available at the time, particularly the German Maxim model, were extremely effective for defense but had critical limitations. They were heavy, requiring teams of 4 to 6 men to transport them. They were mounted on fixed tripods. They overheated quickly, requiring complex water cooling systems. They were composed of hundreds of delicate parts that often jammed in the mud of the trenches. The American Army watched the European war with growing concern. When the United States entered the conflict in 1917, it became clear they would need machine guns, many of them quickly. American forces were drastically under-equipped. There were only a few hundred Maxim machine guns available, woefully insufficient to equip an army growing to millions of soldiers. It was then that military officials remembered a certain Utah inventor who had demonstrated a machine gun years earlier. John Browning, now 62, was summoned to Washington. This time, the generals weren't skeptical, they were desperate. The news from the trenches was horrific. They needed superior weapons, and they needed them immediately. John introduced not one but 2 machine guns. The first was an improved version of his original gas-operated design. The second was something even more innovative, a water-cooled heavy machine gun, based on a completely different principle. Instead of using gases to operate the mechanism, it used the recoil of the shot itself. Each time the weapon fired, the barrel recoiled slightly, and this movement activated the reloading mechanism. The demonstrations were spectacular. Browning's heavy machine gun fired continuously for several minutes without jamming. It was simpler than the Maxim. It had only 40 major moving parts compared to the Maxim's 200. It could be manufactured more quickly and was more reliable in adverse conditions. The officers present were impressed. But there was a critical problem: time. Building factories, training workers, producing specialized tools, establishing supply chains, all of this would take months. American soldiers were being sent to France and dying with inadequate weapons. Every week of delay meant more lives lost. John Browning, at what many would consider retirement age, embarked on the most intense project of his life. He worked 18 hours daily supervising production, troubleshooting manufacturing problems, and training military gunsmiths. His machine gun needed to function perfectly, and it needed to be in soldiers' hands as quickly as possible. The race against time had begun. The most fascinating aspect of Browning's design was its unlikely origins. While most military engineers began with wartime requirements and created weapons from scratch, John had taken the opposite approach. His fundamental principles came from observing hunting, weapons instruments designed for accuracy and reliability in harsh natural conditions. John had spent decades designing rifles and shotguns for hunters. These weapons needed to function flawlessly in the extreme cold of mountains, the humidity of forests, and the dust of deserts. A hunter depended entirely on his weapon. One failure could mean weeks of lost supplies. This demand for absolute reliability shaped Browning's design philosophy. When he observed the gases moving the grass that day in 1890, he was testing a hunting rifle. The revelation that wasted energy could be captured and reused came not from a sophisticated military laboratory, but from a rural shooting range, a testament to how observation, persistence, and creative thinking could solve problems others deemed impossible. This represents an innovative breakthrough that could only emerge from someone possessing profound fundamental comprehension of firearms, not merely as combat instruments, but as precision-engineered machinery. The gas-actuated mechanism John engineered displayed elegant simplicity. A minuscule aperture within the barrel permitted a fraction of discharge gases to redirect into a cylindrical chamber. These gases propelled a piston which subsequently activated the bolt. The bolt expelled the depleted cartridge, compressed the return spring, and was then thrust backward by spring tension, chambering fresh ammunition from the magazine. The complete sequence transpired within millisecond fractions. However, simplicity doesn't equate to effortlessness. Every constituent required design precision measured in micrometers. The volume of diverted gas demanded exactitude. Insufficient amounts would deny the mechanism adequate power. Excessive volumes would inflict undue component deterioration. The timing necessitated perfection to prevent bolt opening, while hazardous barrel pressure persisted. The materials needed to endure extraordinarily elevated temperatures and repetitive impacts. John evaluated numerous different configurations. He experimented with varied gas port diameters, diverse piston dimensions, and alternative spring tensions. Each variation underwent destruction testing, firing thousands of rounds until component failure. Then he scrutinized the malfunction, identified the vulnerability, and engineered a remedy. What materialized from these developmental years was a weapon incorporating surprisingly sophisticated design principles. The system was self-regulating in nature. If gas pressure exceeded requirements, the piston accelerated, but the recoil mechanism absorbed surplus energy. If pressure proved inadequate, the system still operated just marginally slower. This tolerance for variation rendered the weapon dependable even with substandard ammunition or in extreme environmental circumstances. Another ingenious aspect was its maintenance accessibility. The weapon could be completely disassembled within minutes without specialized implements. Components could be replaced in field conditions. Ordinary servicemen could execute basic repairs. This was revolutionary thinking. Previous machine guns demanded specialized armorers for any maintenance procedures. John had transformed hunting weapon principles into a combat instrument, but the ultimate evaluation remained pending. Would it function in the nightmarish conditions of European trenches? When the United States Army authorized Browning's machine guns during 1917, an impressive engineering accomplishment had to be matched by an industrial production miracle. Manufacturing tens of thousands of complex weapons within mere months was a challenge that would test American industry's absolute limits. The M1917, heavy machine gun based on Browning's recoil loading blueprint, was the paramount priority. It contained 40 major components that needed manufacturing to extraordinarily precise tolerances. Each element had to fit flawlessly with others. Variations of even 1/10 of a millimeter could mean the distinction between a perfectly functioning weapon and one that fatally malfunctioned. The United States government mobilized industry on an unprecedented magnitude. Automobile factories were converted to weapons manufacturing. Machine tool companies created novel specialized equipment. Metallurgical companies developed special alloys capable of withstanding extreme stresses of continuous fire. It was a national endeavor. John Browning was at the epicenter of everything. He constantly traveled between factories resolving production complications. When workers encountered difficulty manufacturing a specific component, John redesigned the element to facilitate easier manufacturing without compromising functionality. When questions arose about materials, he proposed alternatives. When testers reported problems, he identified solutions immediately. One of the greatest challenges was standardization. Unlike commercial products where each unit could be slightly different, military weapons required complete interchangeability. A component from a machine gun manufactured in Ohio had to work flawlessly in a weapon manufactured in Connecticut. This demanded rigorous quality control and extraordinarily consistent manufacturing processes. The Colt Patent Firearms Manufacturing Company spearheaded M1917 production. Workers operated 3 shifts, 24 hours daily. Women entered the workforce massively, operating complex machines and performing quality inspections. Many became highly skilled operators, manufacturing components with precision equaling or surpassing that of men who had trained for years. Each machine gun was extensively evaluated before shipping. Testing batteries included firing thousands of rounds under various conditions. Weapons were exposed to mud, sand, water, and extreme temperatures. Those that failed were completely disassembled, and the problems were identified and incorporated back into the manufacturing process. It was a continuous improvement cycle. Production of the lighter version, the Browning automatic rifle bar, also accelerated. This weapon was particularly innovative. It was light enough to be carried and operated by a single soldier, yet delivered automatic firepower. It was essentially the first modern assault weapon, though that terminology didn't yet exist. Within months, American factories were producing hundreds of machine guns daily. Special trains transported the weapons to ports, where they were loaded onto ships bound for France. Each wooden crate contained a weapon representing thousands of engineering hours, hundreds of manufacturing hours, and the hope that it would be the difference between victory and defeat. But the genuine evaluation would come on European battlefields, where desperate soldiers awaited any advantage against an entrenched and relentless adversary. The initial M1917 machine guns arrived in France during early 1918. American soldiers, many experiencing combat for the first time, received rapid training in the novel weapons. Instructors emphasized Browning's design simplicity, demonstrating how to disassemble, clean, and reassemble the weapon took only minutes. Soldiers were impressed by how intuitive the mechanism was. The baptism of fire came during the German Spring Offensive of 1918. German forces, aware that fresh American troops were arriving in substantial numbers, launched a massive attack, attempting to win before the balance of power shifted irrevocably. Thousands of German soldiers advanced across no man's land in dense waves. M1917 machine guns opened fire for the first time in genuine combat. The sound was different from that of German Maxim guns, a deeper, more constant roar. The rate of fire was 400 to 600 rounds per minute, creating a barrage of projectiles that devastated anything in front of them. American soldiers watched in amazement as the guns fired continuously without jamming. What truly distinguished the M1917 was its dependability under extreme conditions. Trenches were a terrible environment for any machine. Constant mud, humidity, fluctuating temperatures, and dust and dirt infiltrating every mechanism. Maxim machine guns frequently jammed in these conditions, requiring constant cleaning and careful maintenance. The M1917 kept working. Field reports began reaching commanders. One machine gun had discharged 20,000 rounds in a single day of battle, with only a brief pause to replace its overheated barrel. Another had been partially buried by an artillery shell, excavated, quickly cleaned, and returned to service within minutes. Weapons that had fallen into mud puddles were shaken out, had their basic mechanisms cleaned, and continued operating. The bar, the lighter version, proved equally revolutionary. Soldiers could advance while carrying automatic fire with them, rather than relying on fixed machine guns in the trenches. This fundamentally changed infantry tactics. Assault teams used the bar to suppress enemy positions while other soldiers advanced. It was a completely novel concept in mobile combat. The Germans quickly realized they were confronting something different. Their intelligence reports mentioned new American machine guns of exceptional reliability. Captured German soldiers reported that their own MG-08 machine guns, while excellent, were more difficult to maintain in field conditions. Browning's weapons had a clear technical advantage. It wasn't just the technical specifications that mattered, it was the psychological effect. Soldiers carrying M1917s or bars felt more confident. They knew their weapons would work when they needed them. This confidence translated into better combat performance. Commanders could plan tactics knowing that automatic firepower would be reliably available. In September 1918, During the Meuse-Argonne offensive, Browning machine guns were present in force. They played a crucial role in breaking through German defensive lines. The constant sound of hundreds of M1917s firing simultaneously created a deafening roar that dominated the battlefield. By the time the armistice was signed in November 1918, Browning's machine guns had proven their worth beyond doubt. But their story was only just beginning. The end of World War I in 1918 did not diminish the importance of Browning's machine guns. On the contrary, it solidified them as the world standard. Armies around the globe studied American weapons with envy and admiration. John Browning's design had established new standards for excellence in automatic weapons. The M1917 became the standard heavy machine gun of the United States Army, a position it would hold for decades. It was redesignated the M1917A1 with minor improvements based on field experience. Air-cooled versions were developed for situations where a water system was impractical. Each iteration maintained the fundamental principles of Browning's original design. The bar had an equally impressive fate. It was adopted by military forces in over 20 countries. Modified versions were used as hunting weapons and by law enforcement agencies. During the Prohibition era in the United States, both police officers and gangsters used bars. Their automatic firepower made them infamous in urban shootouts. John Browning continued working even after his triumph in World War I. He was now in his early 60s, an age when many men would consider retirement. But his creative mind was far from rest. He developed new pistols, innovative hunting rifles, and continued improvements to his existing machine guns. In 1921, he was in Herstal, Belgium, working with arms manufacturer FN Herstal on a new pistol design. It was a normal day at work in the workshop when John experienced chest pains. He tried to keep working after all. It was what he had done all his life, but the heart attack was devastating. John Moses Browning died at his workbench, surrounded by the tools and projects he loved. He was 66 years old. His death was reported in newspapers around the world. Obituaries described him as the greatest weapons inventor who ever lived. Military personnel from several countries paid tribute, but the true tribute to John would come in the following decades, when his inventions would continue to shape global conflicts. During the years between the world wars, Browning's machine guns were continually refined. Military engineers made minor adjustments based on years of use. Materials were improved with advances in metallurgy. Manufacturing processes became more efficient, but the core design remained essentially the same as John had created. The M2, a larger 50 caliber version of Browning's heavy machine gun, was developed in 1933. This weapon would be perhaps his most enduring legacy, capable of penetrating light armor and downing aircraft. The M2 combined devastating power with the reliability characteristic of Browning designs. It was such a well-designed weapon that it would remain in active military service for over 90 years, an absolutely remarkable record. As war clouds began to gather again over Europe in the 1930s, armies around the world prepared frantically, and in arsenals across dozens of countries, Browning machine guns were being pulled from storage, cleaned, tested, and readied for another global conflict. The Utah mechanic, deceased for years, was about to influence another world war. When World War II broke out in 1939, the Metro Browning machine guns were present in virtually every theater of operation. The M1919, a lighter, more portable version of the M1917, equipped vehicles, aircraft, and infantry positions. The 50 caliber M2 became ubiquitous, mounted on tanks, jeeps, ships, planes, and fortifications. World War II was fundamentally different from World War I. Instead of static trench warfare, it was a war of rapid movement, tanks cutting through fields, aircraft dominating the skies, Marines assaulting Pacific beaches. Browning's machine guns needed to function in each of these extremely diverse environments. In the North African desert, fine sand penetrated every mechanism. German MG-34 and MG-42 machine guns, though excellent in many respects, suffered from frequent jams. The Brownings continued to function. British and American soldiers developed an almost religious respect for the weapon's reliability. Tank commanders particularly loved the M2. It could fire at enemy aircraft, suppress fortified positions, and penetrate lightly armored vehicles. In the jungles of the Pacific, the war against Japan presented unique challenges: extreme heat, constant humidity, dense vegetation, and close-quarters combat. American Marines relied on the bar as a squad weapon. In fierce battles on islands like Guadalcanal, Iwo Jima, and Okinawa, the The bar-sustained automatic fire often made the difference between capturing a position and being repulsed. American bomber aviators relied entirely on Browning 50 caliber machine guns for defense. B-17 flying fortresses carried up to 13 M2 machine guns. When formations of German fighters attacked, the sky filled with red tracers. Gunners and turrets swung their guns in complex arcs, firing thousands of rounds per mission. Reliability was literally a matter of life and death. A jammed gun could mean a defenseless bomber. Production during World War II reached impressive levels. American factories produced more than 2 million Browning machine guns in various calibers. Women once again made up a large portion of the workforce, operating precision machinery and performing complex assembly work. The industrial infrastructure created during World War I expanded dramatically after 1945. While other weapons were retired or replaced by more modern designs, Browning machine guns remained in service. In the Korean War of the 1950s, soldiers used the same M1919s that had equipped their fathers in World War II. In Vietnam in the 1960s and 1970s, the M2 remained the primary heavy machine gun, now equipping helicopters in addition to ground vehicles. What was remarkable was not just longevity, but continued performance. Military engineers repeatedly attempted to develop replacements for the Browning machine guns. Prototypes were tested, contracts were awarded, new designs were officially adopted, but time and again, soldiers in the field preferred the old reliable Brownings. The M2, in particular, defied all replacement efforts. In the Middle East wars of the 1990s and 2000s, more than 80 years after John Browning observed gas-moving grass, his machine guns were still in active combat. Soldiers in Afghanistan and Iraq mounted M2s on Humvees and at forward bases. The weapon that had faced German planes over Europe now faced insurgents in the desert. The story of John Moses Browning transcends the biography of a simple inventor. It is the narrative of how an individual with exceptional talent and relentless determination could literally change the course of world history. The weapons he created influenced conflicts that shaped the 20th century and remain relevant in the 21st century. The 50 caliber M2 remains in active service in over 100 countries. No other firearm in history has a comparable service record. From its adoption in 1933 to the present, it has spent over 90 years in continuous military use. Modern engineers with sophisticated computers, advanced materials, and decades of additional experience have been unable to create something fundamentally superior to the design John created with paper, pencil, and brilliant mechanical intuition. The gas-operated principle John discovered by observing moving grass became the basis for most modern automatic weapons. Assault rifles like the American M16, the Russian AK-47, and countless others use variations of the system John developed. He didn't just invent specific weapons. He discovered fundamental principles that defined an entire category of technology. But beyond the technical specifications and service records, there's something deeper to Browning's story. It's about the nature of genuine innovation. John had no formal engineering education. He never attended university. He didn't have access to sophisticated laboratories or research teams. What he did have was careful observation, creative thinking, and a willingness to test ideas repeatedly until they worked perfectly. His design philosophy was elegant: create mechanisms with as few moving parts as possible. Use natural forces instead of fighting them. Build tolerances into systems so they continue to function even when individual components wear out. These principles seem obvious in retrospect, but they were revolutionary in their time. John registered 128 patents during his lifetime. In addition to machine guns, he created pistols, rifles, shotguns, and even automatic cannons. Many of his designs continue to be manufactured and sold commercially more than a century later. The Browning high-power pistol, completed after his death by his apprentice Duden Save, was adopted by more than 50 national armies. There's a poetic irony to Browning's legacy. He was a fundamentally peaceful, deeply religious man who believed in using his talents for constructive purposes. Yet his most influential creations were instruments of war. Millions of people were killed by weapons based on his designs. He never publicly expressed conflict about this, but it's challenging to imagine he didn't reflect on the consequences of his inventions. Perhaps the best way to understand John Browning is to see him as a pure problem solver. He saw mechanical challenges and couldn't resist solving them. The fact that his solutions were used in war wasn't his primary goal. It was the inevitable consequence of living in an era of global conflict. Had he been born in a different era, perhaps his genius would have been applied to agricultural machinery or industrial tools. The ingenious mechanic who transformed a hunting rifle into a war legend never considered himself extraordinary. To him, it was simply work, but his work changed the world in ways he could never have fully anticipated. And more than a century later, his legacy continues to endure, inspiring engineers and reminding us that observation, persistence, and creative thinking can solve problems others deem impossible.